I'm Chuck White. I teach at Spring Arbor University in Michigan, and I am really glad to be here. I'm a science wannabe, and so my doctorate is in church history, but I teach in a small university, so you have to teach a lot of different topics, and it turns out that the prayer partners I have are all in the sciences, and so when we run and pray together, we end up talking a lot about science, and so that's what I want to talk with you about. And I want to begin by reminding you that the old view of the world was that the world was made out of little particles, little things. And the first one who said this was Democritus, and there he is, and he's called the laughing philosopher. And I'm not exactly sure why, but he is that. But he is the one who said that the world is made out of atoms. And atom means means not, and tom means to divide or to break. So something that can't be broken. Now, when Democritus they didn't know anything really about atoms, it's just theoretical. But then probably up through the 19th century, people realized that there were such things as atoms, that elements are made out of individual atoms. But then Ernest Rutherford and others found out, Rutherford shot a beta particle at an atom, and most of them would go through, and one bounced out. And he said that was as surprising as shooting a cannon at a piece of tissue paper and having the bullet bounce back. And what they figured out was that what we thought were atoms and were completely indivisible were actually mainly big empty space with a little tiny bit of something in the center. And so then people came up with the solar system view of the atom, where like the sun is like the nucleus, and then the planets going around or the electrons going around, but it's mainly empty space. Well, so then we've also found out that in the nucleus are protons and neutrons, and then out in this cloud around are electrons, and that's what most people have as their picture of an atom. Well, people spent a lot more money and shot a lot more particles at atoms and at ever smaller pieces. So they've shot pieces at the protons and the neutrons. And what they finally come up with is that the universe seems, at least the smallest thing they've found so far, is called a quark. And there are up quarks and down quarks, and then these quarks have different flavors, and some are strange, and they have all kinds of interesting names. But probably the smallest thing that we know of in the material world is a quark. But even if, and so there are some people who think that maybe we get a much more powerful collider, even stronger than the one down in CERN, and that they'll find they actually found what they call the God particle, which is supposed to be the particle that starts everything. And some people think they'll get smaller and smaller pieces. But the idea that the universe is composed of tiny little pieces of something we'll call the atomic theory. And even though that those things are way smaller than atoms, but there's something way down in the smallest thing in the universe that can't be broken up that's called an atom. And it's a material piece of something. And that's the view that really dominated physics up until about 1900. And what I'm here to tell you today is that view is W-R-O-N-G. It's wrong. And I'm going to show you how people figured out that was wrong and what the implications are. Now, they should have been able to figure this out way earlier than Democritus, but here's what happened. I have these billiard balls. The idea is that there's something like billiard balls, but are much, much smaller, that make up the universe, and that reality are these little balls or little something that make up the whole world. And Carl Sagan, who was an American astronomer, had this view. And at the beginning of his Cosmos series, have any of you seen the Cosmos series? Okay, it's a very famous thing that was on American television, and I think also probably British television. And Carl Sagan, who's an astronomer, begins, and he is walking along a ridge that's a peninsula sticking out peninsula sticking out in the ocean. And there's this wonderful music, and waves are coming. And the first words of this series are, "The cosmos is all that is, or ever was, or ever will be." And this is the materialistic view of the universe, that those little billiard balls, those little atoms, are everything that is, or ever was, or ever will be. That's the view that carried it through the 19th century. And that that everything can be defined in terms of matter. And it's called the materialist viewpoint, or the physicalist viewpoint, or sometimes it's called the naturalist viewpoint. Those all mean the same thing, that the only real thing in the universe is stuff. When we don't know what it is, or some little piece of something that's very small. And that nothing is real but matter. And so, how do you define energy? Well, energy is what moves matter. How do you define space? Space is what matter moves through. How do you define time? Time is how fast matter moves. So the basic thing is matter, and then energy, space, time are other things that exist, but those are defined in terms of matter. What moves matter, what matter moves through, and how fast it moves. And that's all there is in the world. Now, this was a problem for René Descartes, who's the one who restarted all philosophy, all modern philosophy. And he eventually came up with the idea of what people call the mind-body problem. Because René Descartes said that there is mind in the world and there is matter. But people had the mind-body problem. How can something that is immaterial affect the material universe? And the idea is the only way anything can change in the material universe is if another piece of material comes along and hits it and moves it the way a cue ball or the way a billiard ball will move something else. And this still is a big problem for the physicalists. And so how can something that is immaterial affect the material universe? And they say we can't think of any way that could happen. So there's no way anything immaterial can affect the material part of the universe. Another way of asking that same question is, how can the billiard balls move when nothing hits them? Something has got to hit them to make them move, was the belief. So the immaterial world is an illusion. It's not real. It's just something that we imagine. It's like, well, a word that's not on the screen, but the word is epiphenomena. A phenomena is something that happens. A phenomenon is something that happens. And epi means above the phenomena. So like when you go out and you look at the stars and you see the Big Dipper, there's no Big Dipper really there. That's just a pattern. Your mind is imposing a pattern on those stars. The stars are real. The pattern is called the epiphenomena. Or if you see faces in the clouds, the faces are epiphenomena. So the immaterial world is just an illusion that we see in it. It's not really there. It's like an optical illusion, like constellations or like faces in the clouds. The immaterial world is an illusion. And Richard Dawkins argues this. He's a materialist. In a universe of electrons and selfish genes, blind physical forces and genetic replication, there is at the bottom no design, no purpose, no evil, no good, nothing but pitiless indifference. And so the universe doesn't care, but he would also say there is nothing in the universe that's immaterial. So if you push Richard Dawkins, he would agree with the old science. The old science says nothing immaterial exists. There is no God. There are no spirits, no ghosts, no angels, no demons, no life after death. Your mind is an illusion, and your life is merely a chemical reaction. Now, if you take a candle and light it, you are creating a chemical reaction because of the heat that you've put in on the top of that wick. And a materialist believes that the life that's in you that animates your body is basically the same thing as that candle burning. It's just the way for energy to get from an organized state to an unorganized state, for entropy to increase in the universe. Now, it's a much more complex chemical reaction than a flame is, but in essence, your life and your thoughts, everything about you is like a flame that's burning with no more meaning, no more purpose. Okay, but what I'm here to tell you today is that the new science says that's, how did I spell the word before? W-R-O-N-G. It's wrong. And the new science, then this is science that's come in the 20th century and now, of course, in the 21st. Started out, though, they should have realized this, when this man named Maimonides, now nobody knows, he's a mythical character, but he's supposed to be a Greek shepherd who eventually became a king, but his iron-tipped staff stuck to a rock, and that surprised him. And so that force that held the iron tip of his staff to the rock, they named after him, called magnetism. And magnetism works obviously when the things are touching each other, but when they're not touching each other, there's a force between them. And I don't know if when you were little, in the United States, for little kids, we often had these little magnets, little Scotty dogs. You have a black Scotty dog on top of a little bar magnet and a white Scotty dog on top of a bar magnet. Did anybody ever have like that? And you could push them around. Did any of you ever play with magnets as a kid? And you push them around, and even when they don't touch, they move. And so that should have given people a clue that there's some way to move things without touching them because of magnetism. But people didn't worry about that very much. They said, well, we'll figure that out. The next big step comes, we don't know how many years later, but it's Isaac Newton. And of course, the story is that Isaac Newton, when COVID 67, no, it was COVID 63, I think it was 1663, when they closed Cambridge University and sent him home, just like COVID sent us home from universities. He went back to his home, and of course, what's the story about Newton? The idea is that when Newton saw the apple fall, he thought that explains why the moon goes around the earth. That the moon actually falls around the earth. And you can figure that out. And that's how things orbit. Things orbit by getting to have enough speed so that the speed going through space matches the curvature of the earth, so things keep falling off the earth. And gravity does that. And Newton realized that the same force that makes the apple fall makes the moon orbit the earth. And he was able to figure out the force and what the force was. Now, the problem is that since Newton, nobody has been able to figure out what gravity is. That things fall down, yeah, and that masses attract each other, sure. But why? And the answer is because. And you ask the best physicists in the world, and the answer will be because. And when Newton was trying to explain this, you remember, who is Newton's great rival for the discovery of calculus? Anybody remember your history of math? Okay. Pardon? Say it again? Kepler. Good guess. No, but you're off 100 years. But let me tell you a story about Kepler, since you mention it. Kepler was a believing Christian, and when he wrote a book about the planetary motions, and when he wrote the book, somebody said to him, look, nobody's going to understand that book for at least 100 years. And Kepler said, that's fine. He says, God himself has waited 6,000 years for somebody to figure this out. Because, see, Kepler remembered in Proverbs 25:2, it says, it's the glory of God to conceal a matter. But it's the glory of a king, what? To reveal or to discover a matter. And isn't that amazing? We do what kings used to do. When we do science, we are figuring out God's puzzles that he's put into the world. And I think, and this is totally not part of the talk, but I think that one of the main things we're going to do in heaven is science. Because people will already be saved, so you won't have to worry about that. But to figure out the riddles God put into the world, I think that's one of the main things we're going to do in heaven. So if you're a scientist, get ready for heaven. You're going to have a blast. All right. But anyhow, first, I apologize. I forgot to write his name down. Leibniz. Yeah, Gottfried Leibniz. Okay. He also discovered calculus at the same time Newton did. But he corresponded with Newton and said, listen, this idea of gravity is crazy because there's no mechanism by which it happens. You can't explain why that happens. Sure, you can describe it mathematically. You can describe how it happens. But you can't tell me why. And unless you tell me why, you haven't explained anything. What is it, magic? And so Leibniz was really unhappy with Newton and said, that's no explanation at all. But since Newton's time, nobody has been able to come up with an explanation. Gravity works because it works. And it works at a distance. And it's not billiard balls hitting each other. So it's this mysterious force. Well, what else works without touching anything? We know magnetism works, and we know gravity works. What's the other half of magnetism? Well, you're on the right path. Yeah, light. And if you reduce the frequency of light and run it through a wire, it turns into electricity. Yeah. And so here's Ørsted, Hans Christian Ørsted, who figured out electromagnetism. That when you can run a current through a wire and it creates a magnetic field. And you know about the right-hand rule and how that explains you remember physics when you were a kid, explains the different forces and so on. And this is the reason that we can have generators to turn mechanical energy into electricity, but we can also have motors to turn electricity into mechanical energy. And it works, and why does that work? BECAUSE, the 7-letter answer. Because it does. Well, there's a magnetic field. Okay. What's a field? It's where magnetism it's where magnetism influences things. What's a gravitational field? It's where gravity works. Well, gravity works everywhere. And yes, we can measure a field, and it's stronger in some places than in others. And if you take magnetic filings and put them, you can see the force lines in the field. But what is it, and why does it work? Once again, we don't know. But there is something immaterial that works. So the new science says that there is action at a distance. Now, for a very long time, we've known there's been magnetic action at a distance. And then Newton helped us figure out that there's gravitational action at a distance without any physical contact. And Ørsted helped us figure out that there's electrical and magnetic action at a distance. Okay, so that's part of the old science. But it's not explained by billiard balls bouncing into each other. But it gets really interesting when you get to the 20th century. Here's Thomas Young, who around 1800 did this experiment where he shot light through a single slit, and then that light would go through a double slit, but then the pattern that came out would be a pattern of light in some places and darkness in others. And that makes sense if you have waves. Waves will do that. But if you're shooting bullets at a hole like that, that's not what will happen. And so there was a big Isaac Newton and Christopher Huygens had a big dispute about what is light. Is light a corpuscle, or like a tennis ball or a bullet? And that's what Newton said. Or is light like a wave, as Van Huygens said? Well, what's the answer? Yes, yeah, both. And so he figured out that light is a wave and a particle. And sometimes it acts like little billiard balls, but sometimes it acts like waves. Well, waves in what? I mean, you can have waves in water, you can have waves in air, but waves in what? Well, so they thought there was this stuff called ether. But then they proved there's no such thing as ether. Waves in space, which is waves in what? So how can you have a wave when there's nothing to... There's water that goes up and down when the wave goes through. Or when I talk, there's pressure that goes. But what's waving in light? And how can light act like sometimes like a wave and sometimes like a particle? And that made people start to think. Well, then you get our friend Albert Einstein. And Albert Einstein figured out lots of different things, figured out special relativity and then general relativity. And his discoveries led to him figuring out what fission is and how E equals mc squared. And just this year, I figured out how in the world the speed of light has anything to do with how much energy you get out of mass. And there's a wonderful book called Energy Is, Therefore God Can Be, which explains how that equation works. But the amazing thing is that Einstein figured out that energy and mass are interchangeable, and that you can take and we all know about fission or fusion because of atomic reactions. But did you know that if you take an electron and you put more and more energy into it, it goes faster and faster until you get to a limit where instead of just getting faster, as you get closer and closer to the speed of light with an electron, what do you think happens to it? It becomes heavier, exactly. It starts putting on weight. So like if you're trying to run to lose weight, forget it. Because the more you run, the heavier you get, the faster you run, the heavier you get. Now when you stop running, your weight goes back down. Now it's probably not measurable when you're running, the amount, because most of us are not running at like 99% of the speed of light. But if you did get really fast, you would get really heavy. Okay? But that is just odd that the more energy you put into a particle, that it gets heavier. But E equals mc squared helps explain that. Okay, then, so action at a distance we knew about. Matter being energy is something that's new in the 20th century. That matter, all matter can be reduced to energy. Okay? Now, here's our friend Einstein. Here's two other men, Podolsky and Rosen. And they worked together because there's a man named Heisenberg, and he said, you can't tell the speed and the location of a particle at the same time. And it's the beginning of quantum mechanics. And Einstein and Podolsky and Rosen didn't like that idea. And so they came up with what's called the EPR paradox. And the EPR paradox is has to do with quantum entanglement. Now, here's the first time we get to quantum. Now, I've been working on this for a while, and here's the best explanation I can figure out for quantum entanglement. And let's say that a particle disintegrates, breaks in half, and becomes two particles. And one takes off in this direction, and one takes off in that direction. Well, Heisenberg's uncertainty principle tells us that you can't know the speed and location of one of those particles at the same time. But EPR, Einstein, Podolsky, and Rosen said, here, we got a way to do it. We'll measure this one and see how fast it is going, because the other one will have to be going exactly as fast. And we'll measure this one and see how heavy it is, see where it is, and then we'll know where this one is because it's gone just as far from the base. And so that way, we'll be able to figure out what the speed and velocity of each of them is. And they said, but the math in quantum mechanics says you can't do that. And so they said, so that proves that quantum mechanics is wrong and the math is wrong. Well, their big idea, because Einstein said that you can't have this spooky action at a distance. And they came up with this in about 1934. Well, in 1949, this woman, Chin-Cheng Wu, did an experiment and proved that, as clever as that idea is of measuring the speed of one and the location of the other, it doesn't work. You can't do it. And what they figured out is, and here's the best way to explain this quantum entanglement. The two, it's as if when the particle breaks in half, imagine that, what's your name again? Marek. Okay. Marek and I each have a die, with 6 sides and the numbers on them, each put in our pockets. Okay? And here's yours. Put that in your pocket. Okay? And I've got mine, and I'm going to put mine in my pocket. Okay? Now I walk over here, and I roll the die, and I get a 6. He's going to get a 1. Or if he rolls, and he gets, because the 6 and the 1 are on the opposite sides of a die. Okay? So what's on the opposite side of a die from 4? Anybody know? It's 3. Okay, so he rolls a 3. What's going to be in my pocket? 4. And even if I've just been carrying it around in my pocket, it's been bouncing around, as soon as he rolls his die, and he knows what it is, it makes mine. It changes mine. It makes mine whatever the opposite number is. Even if we are now he could tell me. See, he could look at it and say, oh, it's a 5, and so then I'll look at mine and I'll say, well, mine's a 2. Okay, but it takes time for the sound to go between us. But faster than the sound can go between us, the die changes. Let's say he flashes a light. Faster than the light gets to me, it changes. Even if he is on the sun, in some cool place on the sun, I don't know how we'd do it, but some cool place on the sun, and I'm on the earth, how long does it take sunlight to get from the sun to the earth? 8 minutes. Okay. But even with that, we would still know that at the same time, whereas this theory of relativity says that nothing can travel faster than the speed of light. But instantaneously, as soon as he knows it's a 3, mine will be 4. And they showed that there's this thing called quantum entanglement, which even if things are far away from each other, they can affect each other. And the math shows that. And see, the math showed that, so Einstein and Podolsky and Rosen said that the math must be wrong. But then Wu proved that the math is right, and that that's actually what happens. Now, here's another way of thinking about it. There to the right is a sun, and it's in some faraway galaxy. And between us is the Andromeda galaxy, which is about 2.5 million light years away. And so on the other side of the Andromeda galaxy, there's another sun. And that sun kicks out 2 photons at exactly the same time. Well, I don't know which path they're going to take. I don't know which one's going to be gravitationally lensed over the top of the galaxy and get to the Earth, and which one's going to be gravitationally lensed under the bottom of the Earth. But when I make the determination for one of them, it determines the path of the other one, even though that was the decision that was made 5 million years ago. Now, I mean, we're Christians, right? So we believe things that are hard to believe. I think the Trinity is easy to understand and believe compared to that. Right? That a decision that I make today determines what happened 5 million years ago. But that's what our science tells us. This is John Wheeler. He's one of America's premier physicists. And he has this wonderful, this is a diagram he made, and he says, it from bit. And what he says is, as a physicist, he is convinced that the real thing in the universe, the one real thing in the universe, is not little atoms of stuff, but information. And bit is a way to measure information. And he says that all material things come from information. Something physical, comes from bit information. And the reason that ties in with quantum mechanics is that when you look at the die in his pocket that he has just rolled, and you see 6, that's information. And that information is what makes this one into a 1. And there's no physical contact, but it's the information. And it's an observer, it's somebody knowing the information. See, information that nobody knows is not information by definition. Information has to be known. Unknown things are not information. Once it's known, it's information. So in the same way, once the quantum state of that entangled particle is known, the other one instantaneously becomes real. And that's the idea, it from bit. And so what Wheeler argues is that all things physical are information theoretic in origin, meaning that theoretical information is potential information that when somebody sees it, it becomes real information and then becomes matter. Now, am I asking you to understand this? No. But I'm asking you to believe it. Because, like Niels Bohr said, the more you understand about quantum mechanics, the less you believe it. And so, but this is what our scientists are telling us. Okay, so the new science says there is such a thing as action at a distance. It also says there's matters becoming energy, and it also tells us that there's such a thing as quantum entanglement. Okay, well, what else? Well, back in 1952, Watson and Crick figured out what DNA is. And of course, DNA is the nucleotides, and is in that protein, the protein's in the nucleotides. I mean, they code for the protein. But what makes DNA significant is the information that's in it. It's the arrangement of the A, G, C, and T molecules, or pieces of the molecule, atoms, that code for the proteins. And the important part, and what they figured out, the important part of of the DNA molecule is not the physical thing itself, but it's the information that it contains. And so, of course, there's the double helix, and then there's the picture of what the code is, where it says the base pairs. The base pairs contain that information. And it's the information in the DNA that directs the building of proteins. And that's what we're made of. But without the information, there's no us. There's nothing. Okay, so now we've got action at a distance, which we always knew about, and becoming more real. Matter being energy, quantum entanglement, and information. The last piece I want to talk to you about is this one. It's called neuroplasticity. Neuroplasticity is the idea that our mind affects our brain. And physicalists say it's the other way around, that the brain affects the mind, and the mind is just epiphenomena. The mind isn't real. It's just a phenomenon, or just a happening. But neuroplasticity says that what you do in your mind can change your brain. And this has been shown over and over again. One of the easy ones is called the nun study, where there was a certain convent, and the women prayed 5 to 6 hours a day, and as they would die, they made arrangements to donate their brains to science, and they dissected their brains, and they found out that their brains were remarkably similar and different from other women of their same age and stage who did not pray. And the finding is they think that the difference in their brain is not because of what they ate, or how they exercised, where they lived, how long they lived, but because they prayed or they didn't pray, and there are these physical changes in their brain. Now, those are good physical changes. There's bad physical changes, and it's especially in male brains, men who have used pornography. You can tell by once they die, look at their brains, and their brains are different. Now, their behavior is different because they find that it's much harder for them to relate to actual, real, living women who have personalities and make choices, because they're so used to living in this imaginary world with the images and so on. And there's a wonderful book that InterVarsity Press published called Wired for Intimacy. And it talks about how porn actually destroys your brain. And that what you do with your mind changes it. And there are lots of other things. Did you guys know that if there are lots of causes for blindness, but there's some kind of blindness that it's in your eye. Something's wrong with your eye. Well, what they've been able to do so far is they take a television camera and hook it up to a stick to take the electrical charge, and a person can bite down on that stick, and they shoot the TV pictures in electrical form into the person's mouth through the stick. And guess what? Your tongue and your mouth figures out this is not a taste. This is not to be dealt with by the part of your brain that's your taste. It figures out to route it to the visual part of your brain. And your brain will change, and so it will have connections between the visual cortex and your mouth, and so that you can actually see things. Now, they haven't worked it out so that you have like 20/20 vision, you can hit a golf ball or something like that. But it's being improved. Isn't that an amazing thing? That you can rewire your brain and be able to see because you stick a stick in your mouth and bite down on it. How wonderful is that? But that's an example of what we call neuroplasticity, that your mind can change your brain. Okay, so let's put this all together. Because of action at a distance, because of matter being energy, because of quantum entanglement, because of information and because of neuroplasticity, we know that the old materialistic science is dead. There is no way to account for these things if the world is only billiard balls. The old materialistic science is dead. And scientists know this. People who are doing science currently understand this. Now, they don't often think through the implications of this. And I've got this wonderful book. It's this thick, and it's called The Nature of Nature. And in it, it says a quantum theoretical argument against naturalism. So after I had this whole talk made, I got this book, The Nature of Nature, and started reading this article. And the article basically said, Chuck, you're right. And I thought, oh, hooray. But the idea is that in much more complicated terms, it was explaining how quantum mechanics shows that the immaterial world is real. But it says that most scientists have not understood the ontological implications of this, the implications of being. They compartmentalize and they say, yeah, quantum mechanics works and we explain things that way, but we still live our lives as if it were all billiard balls. Well, that kind of cognitive dissonance is not a good thing. So because of action at a distance, matter being energy, quantum entanglement, information, and neuroplasticity, people like Ken Peterson, who works in artificial intelligence and systems design, mainly for satellites, writes this book, Modern Science Proves Intelligent Design. And I was reading this book, and that's where I got my idea, because he begins by saying everything in the universe is formed from energy and intelligence. And I could find many other physicists who repeat this. Everything in the universe is formed from energy and intelligence. I read that and I thought, I wonder if that's really true or why he thinks that. So then I began the study and figured out what I figured out so far. Everything in the universe is formed from energy and intelligence. So because of, as I said, action at a distance, matter being energy, quantum entanglement, information, and neuroplasticity, this is a good argument and a convincing argument that everything in the universe is formed from energy and intelligence. The old science says, don't believe in the immaterial world. Don't believe in God, don't believe in ghosts, don't believe in your mind, don't believe in life. But the new science says that belief in the immaterial world is the foundation for science. If you're going to do science in the 21st century, you have to believe in the immaterial world. Well, why did many people quit believing in God in the 19th century? Sure, Darwin was part of it. But part of it was that God is immaterial. But now we've shown that the immaterial is real. And since we now know that immaterial things exist, we can confidently believe in God. Now, this is not necessarily the God of Jesus Christ, but at least it shows us that there is an immaterial, that there's room in the universe for an immaterial God. And what does the Bible tell us? In the beginning was information. That's what the word is. In the beginning was information. In the beginning was the word. En arche hen halagos in Greek. And isn't that amazing that close to, probably 2,000 years after John wrote, in the beginning was the word, we're now finding out from physics, what do you know? He was right. Okay, here are some of my sources. There was a talk on Einstein's relativity and relativism a few years ago here. Then there's Ken Peterson's Modern Science Proves Intelligent Design. Patrick Daniel McGrath, Energy is, Therefore God Could Be. And then there's my Bruce Gordon, Quantum Theoretic Argument Against Naturalism. That's in a book that he and Bill Dembski edited called The Nature of Nature, Examining the Role of Naturalism in Science. I want to give you information so that you can help people who believe in this kind of reductionistic materialism to see that they are hopelessly out of date, and sadly what they believe is WRONG.